while Anna explaining her research to us, just give you a little bit of introduction, since in this case I know Anna quite well, and so I explain more at a personal level. So that well, I had the fortune of having had Anna as a postdoc in the Institute for Quantitative Social Science at Harvard University, and now after that, stayed at Harvard for some time, and then went to MIT and working mostly on understanding AI, on applying AI in science, and also understanding how AI is used in science. But her career and her training comes already from computer science and working, first as in the University of Cambridge, getting her PhD, applied to some of the work that we were doing at CERN. I believe with the Large Hadron Collider, right? The data from the Large Hadron Collider. And I always had an interest in understanding how we do science, how we can do it better from a computer science point of view, than meaning to be more reproducible, also to have the provenance, the data provenance of all the steps, how we capture that provenance. She worked with Marcus Selzer, a renowned computer scientist, is an expert on reproducibility and data provenance on that. And well, we worked at some point, we all collaborated together. So she's still interested in all these topics, but now in the context of using AI. I think this is very relevant to a lot of the work that we do at BSc, a lot of the work that we do in computational social science and humanities. So I'm very happy to have her here. Thank you.
Thank you. Thank you so much for a wonderful introduction, and thank you all for being here. And I'm really happy and honored to be here. However, I'm still struggling, regardless of my diplomas, to cast the screen. Yes.
I can continue talking while you need to set up.
So the thing is that I have on my computer, I have a presenter view, and I would like to keep my presenter view.
You need to share. Maybe share the two. Mirror.
Yeah.
You don't right. You don't want to mirror exactly. Right?
Yeah, I don't want to mirror exactly.
So just mirroring. So, but there is a way that
this one is a share. I mean, share. It is already shared on Zoom.
But we don't see it here.
Yes.
I think you should be able to share like this other screen, not the Zoom one, you know?
Yes, but I don't want to share the whole screen.
But maybe if you share the entire PowerPoint, is that a PowerPoint or is it?
Compartir el seu Zoom.
If you do that, then you look. If you stop. Maybe.
Is there a way to like present, like click present in your app?
Right.
I think you could set up that big screen as a second screen. And then when you're sharing it,
You have the slide, right?
No, I don't have the.
What is your PowerPoint? Or is it a PowerPoint or
it is a browser?
it's a browser?
Slide.
Okay, so what is
Keep it as he was saying, as a second screen, so that you can just keep it there, but not.
It's very different than what I see usually. So, screens. Okay. Yeah.
Let me. I think I am displaying.
Well, apologies. We started late because the room was taken. So otherwise this would have been figured out before. So the other possibility is
Because I think that from the Zoom menu, you should be able to choose which screen.
exactly.
So
That's why
if
you
click
share
in
just share the screen, but not the advanced. You go to screen.
Yeah,
You
and just
share your
the one that
your
has, like,
Safari,
this
this
one.
one. Share this one. Now share. Okay, select. No, but you see.
Yeah.
And then share. And then I think that from here, if you do
It needs to mirror, or else it doesn't.
And
doesn't
you
work.
don't need to mirror then.
Yeah.
Yeah, and if not, we'll just do it in this way, but we can go back to the mirror. Okay, now.
Yeah, and now you have to mirror it, and
Just
we're
do
good to go.
mirror, do the mirror now. Mm,
I don't know where the mirror thing is though.
Yes, I also cannot find the mirror thing.
You had it before, right?
Yeah, yeah.
Mm, This one and then.
Okay.
Oh, choose content. Here it is.
I'll start mirroring, no?
Is it this one or this one?
If you click mirror all or.
And
Ah,
now,
okay, okay, we're good.
vale, now we should be able to see. I mean, it wasn't exactly what you wanted, right? Because you.
Yeah, it is not exactly what I wanted, but okay.
And then, like, you can use my computer to read your notes and have it in another presenter mode there.
Yeah, I think it's a little bit late for that.
Otra vez.
Mm,
But now we see that it's not connected. Why is it not?
yeah, no, it should be.
No, no, it should be working.
Yeah, it
Because
should be
if
working.
you exit the full screen, does it,
But don't stop mirroring because I think you need to do it again.
Okay, let's do like this.
Maybe now, okay, okay, we see.
yeah, this is the best we can get.
Okay, is it also mirrored in the on Zoom?
That's it. Yeah,
Yeah.
yeah, I mean, we're, just don't touch
Mhm.
anything else and that's
No,
it.
right now it's fine, if
Yeah.
you're okay with it.
Okay,
Yeah, you can deal with that, okay.
okay. So, yeah, sorry about the delay. So, okay, I think maybe it's going to be easier if I walk around and then show things my screen.
Maybe don't as loud as possible.
Oh, yes, I try to talk as loud as possible. Is this the microphone for, can you hear me? Or should I turn on the microphone?
In the room, they will hear you in your voice, and at home, your mic here is where they're going to hear you.
Okay.
Because if we use the mic.
Okay, okay. So then I should speak here so people can hear me on my computer. Even louder. Okay. So welcome everyone. We are going to talk about my research, my recent research, some of the things I actually will present here for the first time, and some things I already been working on for over a year. It's on essentially, I'm looking at AI frontier and what's happening in the AI space in science. So the transformative role of foundation models across the disciplines, and also how it influences other aspects of like sectors, industry, academia, politics, and so on. So my first slide it was an introduction about myself, but Mercedes did an excellent job to introduce me. So I'm a research scientist at MIT right now. I was previously working at Harvard, also working with Mercedes for a long time. I was a postdoctoral scholar at the University of Chicago. I did my PhD at University of Cambridge and CERN, where I worked with LHC datasets. But my passion is open science, open data, research reproducibility, looking at democratization of science, looking at AI, software, and hardware. Okay, so here you have some more information about me. Add me on social media. I would love to connect. I'm typically the one who like adds people.
The slides zoomed, so it's through internet. It's like you can see the entire screen.
Oh, okay.
Yeah.
Okay, I'm going to do that again. No, it is. I am. Interesting how many PhDs we need to solve this problem. Okay. So yes, I'm one of these people who have 1,000 tabs open at all times. Okay. I think now it should be good for everyone. Yes, okay. Yes, so, okay, let's dive in. So, yes, transformative role of foundation models. So essentially, we want to understand the AI's role in science to evaluate productivity, innovation, emerging challenges in research, reproducibility, democratization, and so on. We want to inform policymakers, funders, researchers, and also point to some challenges, something before they cause bigger challenges. So, of course, this research has already been not done, but many people have looked into the impact of AI in science. And so far, much of the research was actually looking at keyword level analysis. So essentially looking at either one single word or pair of words, such as, for example, machine learning, convolutional neural network, deep learning, and looking at how these things appear in research or in scientific publications and try to draw some conclusions from that. However, just by looking at these keywords, we are not able to get a very nuanced understanding of what is really happening, of what people are trying to do, whether this is the development of AI, application of AI, or just referencing in some sort of survey or else, or conceptual mention. So that's why here, what we want to do is to use language models that are now very popular to really understand the context of this use and to look at full text citation context that will provide us with more detail and more accurate view on how the foundation models are actually adopted across science and what is happening with them. Okay, so before I go any further, I'm going to introduce a definition, and that is the definition of a foundation model. Now, maybe you've heard about foundation models. I'm sure you did. And maybe you heard also a hand-wavy definition of a foundation model, because we don't really have anything that's very concrete and anything that's very like mathematical or formal. The definitions differ. Many people, institutions, even governments have introduced a definition of a foundation model. And typically, they have some common themes, but the one that we introduce is also based on existing ones. We say that the foundation model is a pre-trained model that requires significant investment in this pre-training. So it's significant investment in data, computational resources, expert knowledge during this initial development, but it can be efficiently shared and reused among a variety of downstream tasks and applications. So it is not only valuable for its architectural design, but also for this broad versatility in the applications and tasks. So that's a definition that we employ. So essentially, every time we use a model where we can say in the code from pre-trained something, we talk about a foundation model. Okay. And as I say, like even EU has its own definition, the US government has its own definition, Stanford AI Center has its own definition, but these are more or less all similar. So let's talk about the main research questions of this talk and of my work. So it essentially spans many different topics. So first, we're going to talk about the models themselves. So what are the emerging trends of AI model development? What models are now in? What are out of fashion? Then we are going to talk about transformative role of AI in science. So how AI is used in science and what we can infer. Then we are going to talk about collaborative work, so collaborations, groups, teams, and research impact. Next, we are going to talk about geopolitics a little bit, geopolitical dynamics in AI development and use. And last, we are going to talk about AI democratization. So essentially, by looking at these, at the papers, at AI context, and teasing out this how one uses the models, we can essentially answer or try to answer and inform many questions. Some of the questions are these, and they seem quite diverse. So first, before we talk about any results or any insights, let's talk about methods, so you know exactly how this research went. So we investigate the use and impact of foundation models in science by compiling a comprehensive database of these foundation models, so released by the end of last year. And we identify the set of papers that cite these models, the foundation models. And then we download all of these papers, and using the citation classification with a language model, we analyze how these models are used, and we then compare them by size, by origin of the model, disciplinary application, intended purpose, and academic influence. Okay, so let's look step by step. So first, we have this AI index database. So we identify and collect data on foundation models. So we have about 2,000 foundation models that are built and released until the end of last year. And we gather information such as the model size, the model origin, and these models are coming from different paper publications, but also from just Hugging Face, from GitHub. And there is already a database that essentially we reuse for this purpose, and that's created by Epoch organization, Epoch AI. So starting with the Epoch AI database and manual review, we had a team, a cohort of undergrad students who were doing this work for us. They were essentially collecting the information on the model size, availability, openness of the model, and where the model can be found, and if it is a foundation model or not, according to our definition. Then we retrieved all the papers that cite our foundation models. And for that, we use Semantic Scholar database to retrieve 270,000 scientific papers citing these models. And then we extracted 1.6 million context sentences that essentially reference these models. So when I say sentences, I actually mean a context, and that is going to be like a 3-sentence window that then we use for classification. So our first step essentially is to extract paper metadata. So we extract paper metadata. We want to understand who are the authors, where is this paper coming from, what is the institution. So for that, we use an open source model, MetaLlama 3.1, and then we extract paper metadata. So how does that look like? Something like this. We have a paper, abstract, introduction, references, and we find that header of the paper. And then we say, language model, tell us who are the authors, where are they coming from? And then the language model says, this author is coming from the States. The institution name is MIT. The institution type is academic. And the author is Neil Thompson, who is the director of the lab. Okay. And then what we do next is that in the next step, we measure AI adoption with citation intent classification. So we use this 1.6 million sentence context to classify them according to our criteria that you will find out next. Okay, so how we classify these contexts. So we want to understand the AI engagement level. So we want to distinguish in between high engagement and low engagement, or like advanced and non-advanced engagement of with AI models or foundation models. So we classify these contexts into 3 groups. The first group is model citers. And this can be model citers that cite a paper as a context or background or previous work or compare and contrast. Then we have model users that directly use the model for their research. For example, how we here use Llama for our research. So we essentially use AI to understand how AI is used. Yes, so, and then we also have like a model customization. So people who take a pre-trained model, change something, change the model weights, and then we want to tease that out from the text. So essentially, model customization is the highest level of AI engagement. These are people who know how to work with the models, who know how to do this neural net surgery on the weights and essentially changing the layers. Model users are the ones who use the models off the shelf. So we need some expertise, but not as high. And model citers, potentially, we can postulate that these can be people who can just cite the model, but not necessarily deeply engage with the models. Okay, so this is the pipeline. And then finally, we get also this database on model customization and use. So, okay, now you understand the pipeline. I'm not sure what's the typical etiquette, but if you have any questions at this stage, you can ask. Yes.
Why did you use Llama for extracting metadata and GPT-4o-mini for measuring the AI adoption?
That's an excellent question. So in the beginning, we started off with just open source models and free models because they're free. And Llama was performing very well with because the context window was small. We just had a few sentences with essentially author names and affiliations. So that was easy to identify. We got pretty good accuracy. But then when we tried to use Llama again for the classification of the sentences, every time we compared that to our ground truth, we essentially saw like a lack of accuracy that context classification turns out to be quite difficult for language models. And then we were in search essentially for finding the best method, how we can classify. We were using multiple language models, one after another. And then somehow when, somehow it turns out that really OpenAI models are the best performing. And when OpenAI dropped the prices for these models like a few months ago, we decided that's probably like a good investment for us because these are the most accurate models. Even though we have like 1.6 million, the prices are still so low that it's, you know, that it's not going to break the budget for us and we will get accurate results. Okay, I will then continue. So right away, let's start with talking about some results. So emerging trends in AI model development. So I mentioned we have this database of 2,000 models. We can see that language models dominate. So over half of all of our foundation models are language models. However, before language models were so trendy, we had a lot of vision models that were very popular some years ago. We also see a lot of biology models, multimodal models, and even robotics models. And these models are also on the rise. So even though LLMs dominate, vision, biology, and multimodal models are also there. And so we also want to see which models grow fastest and which are on the decline. So biology, video, and multimodal models show explosive growth at over 100% growth, or like 57 for the last one, respectively. And then we also see the shifts of the trends. So while language models remain the majority, development is rapidly expanding towards specialized domain-specific applications. Yes, and one thing I like to mention is that robotics models are now also on the rise, foundation models that are just for robotics. So what are some of the things that we see? So here we have a timeline. So over the years, we can see, so this is a cumulative number of foundation models, and they are stratified according to the model size. So we have some model sizes that are small, and then we have models that are from 100 million to 1 billion, from 1 billion to 10 billion, 10 to 100 billion, and over 100 billion of parameters. That's how we measure the model size. So in the number of trainable parameters. And we can see that over time, first we had a lot of smaller models, and now more in the latest years, we have the rise of big models. And then here on the right-hand side, we can see the growth of these models. So we can see that models that are actually the most rapidly growing over the past 3 years are actually the largest models. So what does that mean for us? What does that mean for scientists? That means that the scale of science is changing. So we are essentially pushing the boundary of what is possible. So by creating this type of models, we as scientists will need to adopt how to use these models effectively, meaning that we will need to have more infrastructure, more data, more space, more compute to work with these models. So the scale of science is changing. Then when it comes to the model openness, we see that there is a lot of open source models, and open source has really changed the space of AI, as you probably know, with Llama models, with PyTorch being open source, and the other libraries and models. However, here we divide, here we have 3 groups. So open source models, closed source models, and unreleased models. Open source models are the ones that just weights are available. So that's how we define open source models. It's probably like a more rudimentary definition where just the model itself is available, but not really code or anything else. We do look into that also, but here this is just like open weights. And then we can see which models arise, growth more. And we see that closed source models are actually growing the fastest. So maybe this shift in open access is actually in AI is changing. Maybe now after this initial spark of open source, maybe things will become more proprietary and more closed source. Okay, so that is just on some like general trends. So now let's see what's happening in science. So, of course, something that has already been observed, we see a big surging scientific adoption. So the proportion of scientific papers using and customizing foundation models has grown exponentially since 2016. So here we see, according to our different classifications, background citations, model uses and model customizations, how all of these, this is a log scale, so how classes rise. And then we also see, this is the foundation model, this is our foundation model database, essentially looking at rise, how they have changed over the years also. So all of these are naturally exponential. And then across the fields, this is how the plots look like. So some of the fields are very advanced in adopting AI. So for example, until the end of the year, linguistics and computer science use most AI. And then I think that for the linguistics is like 13% and computer science. And then engineering, mathematics, environmental sciences, biology, medicine, physics, psychology also have very significant numbers of AI adoptions. So adoption rates vary widely across disciplines. Linguistics leads at over 30% adoption. Biology shows the fastest growth in customization of the models. while physics lag behind. And we are also able to observe what are the model sizes or what are the model types that people use across the fields, and the fact that they vary across the fields. So here we can see across the different sciences how these distribution plots look like when it comes to the users and model customizers. So we can see that there is a preference for smaller models. So despite the growth in building ever larger models, actual adopters favor small to medium-sized models, including a practical mismatch between supply and user needs. Indicating, so what's happening is that, so what we think is actually happening is that even though, say, Llama releases models that are 8 billion parameters, 15 billion parameters, and 80 billion parameters, the first one that people will try to use and try to adopt for their applications will be the smallest model. That's actually the easiest to work with. And then if need be, they'll maybe go to the larger models also if the compute and the infrastructure allows. Okay. Now let's talk a little bit how collaborative work looks like working with the AI models, and how the research impact looks like working with AI models and different AI models. So we see that collaboration is rising. Research using foundation models is increasingly team-based, with average author counts growing steadily over time. Model builders now average 13 authors per paper, compared to just 3 in 2012. We also see that fields like medicine and physics show higher level of institutional collaboration, while smaller teams can still adopt large-scale models, indicating resource alone does not dictate adoption. So what does that mean? We can see that in a plot. That is, so this is a plot showing number of authors among model adopters. And when we talk about model adopters, these are both model users and model extenders, customizers. And then we can see the parameter count. So this is the size of the model. And we can observe linear association, positive linear association, meaning that number of authors is slightly associated with parameter count, but more importantly, actually, we can see that even a small number of authors can work with really, really big models. So this is not a strong linear association, definitely not. Okay, so then when we look at author list length, again, the similar trend, similar plot. So we see that there is definitely some, so author list length versus the model side, there is a positive association according to this plot, but still we know that smaller teams can still work with really massive models. Now, when it comes to citation counts among foundation model adopters, the question is, are people who work with really large, advanced, complex models, are they awarded by getting more citations, more recognition in the sense that they can publish in high impact journals? And we see some association. Even though like our errors are really big, we see that people who publish, so papers where the adopted model is really big, so 10, 100, over 100 billion parameters, have mean citation count that is higher. Okay? And the similar thing is happening with journal impact score. So we see that the bigger the model means potentially higher impact factor of the journal. Okay, so that is another observation. So any questions so far? Yes?
Is it true that
these kind of models are used in journals or in conference or just archive papers. You find that my experience is that most of these papers presenting models are just archive papers. They have no incentive just to go through a peer review process.
Yes, so that is for the model adopters.
That's for the model.
Yes. No, but it is, I mean, you are pointing to something that's a very good point. And that is that right now, essentially in the AI space, most of the papers using the models or creating the models, they're being published at conferences. And conferences do not really have the journal impact factor. So they are a little bit different. They have different scores. And so that's a really good point. Also, another good point is that the natural limitation of this research is that we work with open access papers. So most of these actually come from archive. So yeah, that is that is something that is also important to mention. So most of the papers actually do come from archive, but not all of them, because we use Semantic Scholar. So whenever we can retrieve a paper in its published format, we are going to do that. We're not, we are going to use the preprint, and also the information where the paper is published is going to come from the Semantic Scholar metadata. But then, yes, to your point, so here, when we talk about mean impact factor for the journal, there is a small footnote that it is, so I think that this is meant to say, like, we work with a fraction of the data, so 17% of the journal, so I think it is of the data.
Another question related to that, because I don't know if you looked at it then by the disciplines that you had looked at before, right? I mean, compare that with the citation and so in the factor with so the discipline, because I just wonder if there are only a few so in order to adopt open foundation model, like it needs to be open source, right? You need to be able to deploy it and change it. And I wonder if there are only a few LLMs or other foundational models that are driving that high citation, but it's only caused by a few of them. You know what I mean? That so just wonder where are all these comes. So
yeah, that is an excellent.
It's probably only a few that actually are much.
Yeah, creating the spike. Yes, that's an excellent point. Yes, these are excellent questions. I should create that plot across the disciplines. How does this look like? And but you're also pointing to something something that I didn't mention and was important. So you said oh my God, now I forgot. That
the open source.
yes, the open source. Yes, so that is the important information. So we do collect information on how the model is released. So we have a grouping where the model is released open access. The weights are available online, so anyone can download them and work with them. Then we have many of our models are actually API accessible. So through like API. So even though, for example, even in this particular research, we use Llama that we download and work with ourselves, work with it. But then we also have part of the research where we classify sentences with OpenAI API. So we do also capture that case. That is that work is done through OpenAI.
Yes, you would not call that adopting.
We call that model usage. Yeah. We call that model use.
Right.
Yeah.
That's what I mean.
Yeah. Just, but then
be open source and that's the only way.
yes. Model extending is then model extending or model customizing is yes, only available for the.
That's what I say, that it probably is driven by only a few of these conditions.
Yes, these are very good questions. Okay, so then I am, by the way, totally unaware of the time. I cannot see that on my screen, so you'll need to. Okay, excellent. So geopolitics, now we are coming to some interesting topics. So obviously our affiliation metadata and the way how we classify that allows us to look at some other interesting questions, like what are the countries that drive AI progress? So let's talk about the geopolitical dynamics and the AI development and use. So here, model uses and customizations. We call both uses and customizations adopters. And we can see from our data set that, again, it has a natural limitation that is mostly like English language centered. We can see that the countries that dominate model use and customization are the US and China. And because this is a log scale, so these are like the ones that are most dominating ones, but then we also see that Europe is here. We can see Australia, India, Canada, and yes, other countries. So in the US, me coming from the US, there is a really big discussion and a really big tension on what's happening with the US and China, and that race and being neck to neck the two countries, and also what it means for like the geopolitics and the state security of the country. So the US and China are the dominant players in AI, with the US investing far more, both the private and public investment. So it is order of magnitude larger in the last year. However, China leads in overall model adoption by 7%, showing that investment alone does not guarantee impact. So when I say here leads in overall model adoption, that's the scientific model adoption. Okay, so let's see how does that look like. So here we are just only going to compare US and China. On the y-axis, we see the model sizes that are adopted. On the x-axis, we see how these things change over time. And we look at only the two dominant players that are order of magnitude more present than any other country, so US and China. And in computer science, we see the two countries are essentially neck to neck. In what is this field? Biology, we see US is leading. And in mathematics, engineering, physics, medicine, China is leading. However, when we compare these plots to the general investment and the fact that US is investing 10 times more than China, that raises questions what's happening with US, what's happening with all of these dollar bills being invested in AI in the US. And the fact that also we are here capturing just a fraction of the Chinese papers, they're probably also publishing in Chinese language, right? So that's something that is out of the scope of this research. Okay, here we can see some model distribution. So when it comes to model building, we can see that China is building bigger models than the US. Model customization, we can see that when it comes to model customization and usage, China is working with smaller models. The US is working with slightly larger models. Okay. And we also observe different scaling strategies. So the US supports a diverse ecosystem of smaller models encouraging customization, whereas China focuses its resources on fewer, larger flagship models, shaping distinct paths for innovation and collaboration. Yes, I think that came from a table. Okay, so now let's also talk about impact. So here we are going to compare China and the US. And again, we are going to look at the model sizes each of the countries adopts and works with, and the citation count, so recognition through citation count, and journal impact factor in 2023. So here, a citation count per adopted model, we see that essentially in the US, working with bigger models is rewarded with more citation counts. And but in when it comes to the journal impact factor, we can see that the US typically gets, or like has papers in journals that are higher quality or like higher impact factor, except for this bin over here with smaller models. Okay, so that is something that is also one of the conclusions of this study is that on paper, China uses more models and they publish more papers using the models. But when we look at the quality of research, at the metrics such as journal impact factor, we can see that the US research typically is in journals that are more prestigious or have higher impact factor. Okay, and
So I say that, do you see, remember that in the metadata that you were getting from the big papers you were talking also, whether it was an academic, what type of affiliation was that? Have you looked at the type of affiliation for the website and the largest, I mean, for the papers that use the largest model, because I wonder if it has to be one of the OpenAI or
yeah.
you know.
Excellent. So that's an excellent question. So Mercedes asked, yeah, Mercedes asked, what do we know about affiliations? So she says you classified affiliations as academic or industry. So what's happening with those? Even though we did not prepare this question, this is an excellent introduction for my next slide, which talks about AI democratization and actually what is indeed happening with the industry academia tension. So let me tell you more about that. So as Mercedes also said right now, industry does dominate model building. So we see that the majority of large foundation models are developed by industry players with limited contributions from academia and non-profit. So we can see in this plot really nicely, even this is a cumulative share of models, but we can see that somewhere here in 2018, this switch happened such that industry, academia that was traditionally building models and caring about AI, the switch happened and the models that are now built are mostly actually coming from industry. So now in in the most recent years, most of the cutting edge models, most competitive models are coming from industry. So industry does overtake academia in model development. And of course, that has also been observed. There are many reasons for that: compute resources, the race for talent is some of the reasons why industry does that. When we look at model builders, so okay, we know that industry also uses bigger models. Academia builds smaller models and was historically building smaller models. When it comes to the model customization, industry is customizing bigger models and using bigger models, and academia is using and customizing smaller models. And even though, yes, so maybe now another like natural question is, why do we observe so many papers that are coming from industry and are using and customizing the models? That's a very good question. But for some reason, even though, of course, academic papers are much more present, there are also a lot of AI papers and papers that adopt AI coming from industry. And that's where we see these results from. So Mercedes also mentioned Meta. So here we see Meta just over here. Model builders institutions are Google, Meta, Microsoft, and we kind of see them over and over again. They are very much present. OpenAI. When it comes to model development, Stanford University was competitive. Several places in the US, China, Oxford. And then when it comes to model users and customizers, we see that Google, again, Microsoft and Meta are some of the most present model users and customizers again. So they appear both as model builders and model adopters. And we see several places in China that I'm not going to dare to pronounce. And yes, in the US, a few places like Stanford and Carnegie Mellon. Okay, so we also observe when we look across disciplines that industry-built models are widely adopted across disciplines, shaping research directions and dependence on private infrastructure. So we can see here we have two axes that show model size difference. So model size used by industry versus academia. And then this is model size customized by industry of academia. So we are trying to capture the difference in model sizes used and customized, and where the industry versus academia and where this falls into this grid. So here in this quadrant, that means that the industry customizes larger models and uses larger models. Whereas if something is in this quadrant, we can see that academia is larger both in customization and usage. And then these two are more neutral quadrants. So we can see that across the disciplines, actually things are happening in industry, but not just in academia. And across the fields, they are pretty much present in industry, and both are customizing and using bigger models in industry. So what are the implications for democratization? So this concentration of model building and using in industry raises concerns about equitable access, openness, and the long-term capacity for truly open, reproducible AI research. And we can also see that in one more plot. So this one is shows essentially that the researchers prefer open source AI in most disciplines. So these are open weights models, but then we can see that they are more adopted than closed source models. Okay. And yes, there are many problems with using closed source models with the OpenAI models, these silent updates, versioning of opaque updates, and whatnot. But that's a whole new discussion. So summary. So in summary, we learned all of these things. We spoke about foundation models. We spoke about the landscape of foundation models. LLMs dominate, but growth is shifting. So we see that LLMs are majority, but we also have a lot of biology, video, multimodal models. We saw rapid scientific adoption. So use and customization of foundation models have surged. Small to mid-sized models are preferred in sciences. So despite bigger models being built, it is much easier to work with and adopt a smaller model. Collaboration and interdisciplinary research is rising. So we can see that research is becoming more interdisciplinary and the research teams are growing. Geopolitical aspects is also really interesting. So it shapes AI, the tension in particular between US and China that lead in AI, but also they have different scale, adoption, and strategy. And we can also observe this tension or difference in industry and academia, so potentially limiting democratization. So industry dominates model building, which raise concerns about equitable access, research infrastructure, ethics, and so on. So thank you for now, and I'm excited to hear your questions and comments. Mhm.
I can have my vote, I guess. I will wait for my question. Marta.
Mine is a very simple one. So when you talk about collaboration, you talk about collaboration across disciplines, but not about collaboration between industry and academia. So models are just built by industry or by academia. There's no collaboration between them.
That's a very good question. So it is, yes. So typically, if we stratify such that one paper can either be industry, academia, or both, we will typically see that in the industries like that academia is the worst performing, then comes industry, and then actually the best papers are coming from collaborations of both. So both in terms academic impact and the citations and adoptions. So papers coming from both are going to be like the most rewarded. And also the same thing is with the US and China. So for example, maybe China, maybe it's going to be the worst, and then US, and then actually collaborations in between US and China is going to be the most rewarded, has the best impact. But in economics, typically, and I work in a group where we are a lot of economists, not me, but the group is, what is happening is that we would take one single paper and then we would split it according to the industry contribution versus the academic contribution. So for example, if there is one author in industry, one author in academia, and they write together a paper, we are going to apply 50% weights for that part of the paper and 50% weights of that part of the paper. So then essentially we split everything across the papers per industry and academia. So we don't really look at the collaborations across the sectors.
That would be, and especially for policymakers, if some of the results are for policymakers, is to see what is the value of industry, academia, collaboration. To me, this is the most interesting thing that. From a point of view of me helping policymakers.
Following the story, my question is very related. Okay. I was wondering that it happens once with open source, that companies start taking open source projects to build products with a lot of value. And my personal take is that right now building a model is more engineering stuff, and industries are taking the ideas from academia to build or to actually deploy these models. And I want to see which are the true contributions of academia in this company models. For instance, OpenAI is releasing these reasoning models that released recently. But if you see the technical paper of explaining this kind of models, there are a lot of citations to fully academic contributions. I know some people that have published a paper in NeoRIPS, and the papers have been used by OpenAI to build this new model. And well, that's my idea. And now OpenAI is gaining a lot of money. And for me, finding a way to traverse this history will be very interesting.
Yes. Yeah.
It's just okay. Your idea. You're not allowed to get a lot of profit of your model because your ideas are our ideas, our strategy ideas. So at least you have to return back some.
Yeah, so let me see if I understand your question. So you're saying that industry is a lot of citing and piggybacking on the research that was done in academia originally, but then what is your concern? Is it like more recognition for that, or?
My thing is that these models, in fact, are just an engineering effort that is built by OpenAI, but they rely on the public research to do that. So that could be interesting for institutions to say, okay, you are building new models from a public effort, so you just have to return back some of your profits.
Yeah.
Maybe
I mean,
yeah,
that is yeah, that's absolutely true. Yeah, that's absolutely true. I mean, and that's also they would look for PhD students who did a lot of technical work in AI, and then they would bring them and make them like also a research scientist staff at OpenAI. So that's like a typical thing, and it's also yes, I think historically we've seen this type of things. Like say the development of the computer chips was first happening in universities on a local scale, and then eventually that was transferred to industry that would like scale it and make it usable for big populations. But yes, absolutely, so much of this work is based on like purely academic work, and we see that shift here in one of my slides, where we see that like actually we are like living now that history where in 2018 this shift happened, that most models are being built by industry.
So I think what I understand more just that, so build our own models. And it is true that there's things that are being done by public research and but private companies, especially tech companies, they're actually doing a lot of stuff. The problem is that they don't share.
They do a lot of research.
But they're actually doing a lot of research, and we are making use of a lot of, whenever this is kind of big papers coming out, we just go through it and say, okay, which kind of things can we do with the resources that we have? Because the good thing that they have is that they can throw millions of it. So they can train thousands of models just to see which one works best. We kind of do that, so access to my instruments very limited. And they also can steal data, which is because we can. Yeah, it is great because like variety of data basically helps models become better, right? So so we're really stuck to our CC0, CC5 data. So I do think that that kind of trend is shifting in the sense that they do have things that public research do kind of do the heavy lifting. To my mind.
Doesn't make it right.
Mhm.
So just I think that you got considering that, let's say the goal is to benefit humanity with whatever knowledge we have, and you are the regulator, what would you propose how this is working to be ended?
Oh, I don't know. That's a very responsible question. I have not done that homework. What I mean, yes, I think. Mhm.
You can answer.
Yeah, I can. But I mean, there are some like really concerns that are brought up that are just really, really, really wide enough and broad enough and true. So, for example, whoever serves the model, whoever builds the model, and those interests are already like incorporated in the model, the interests of that company, and the ethics of that company or the ethics of that country, and that is something that has been really observed. For example, if you ask models about certain countries, about their political views, about their you can tease out also like how they see gender, how they see minorities, how they see, yes. So it is, I think it's either, we could either strive to have, and yes, whoever has whoever builds the model, that model is going to be standing for the principles and ethics of that company. So the argument is that that's why we should have also state-led models. So state-led models are going to be the ones that actually, in theory, represent the people and like peoples and values and those things. Or we can have like very, very many models, so then they kind of compete against each other, and then these things like even out. But yeah, so maybe I would say more state-led efforts on AI.
I don't know if you already did or if it's possible to do with the methodology you have developed until now, but did you measure how successful is the usage of these models in each of the fields? Because maybe they can mention some specific models, but we don't know if they say those were good to solve the problems they were doing, and if they were comparing some of them and some were working and some not. So I don't know. We know that everybody's trying, or most of the people is trying to use AI, but how successful is the use of AI?
Yes, so that's what we're trying to. So our classifier, the language model, is trying to actually classify against those sentences that we have like that compare or contrast. So that's called when you like compare like many different models and say like, oh, this model is better than that model. So we want to classify that as a background or as a context, just a citation, not as a AI engagement. So yes, we try to capture just like pure use of the model or pure customization of the model.
I think probably the citation is the best. I mean, we don't have many other ways of measuring the citation. I mean, unless you really do analysis of the text and the context of the audience, or perhaps or patterns or innovation from that, right? But the citation plot that you show is the best way to have the impact, right? It's the best way to measure the use of that, maybe had an impact because the community has cited
That's
the
true.
work.
Yes.
We can see what are the most used models in different disciplines. For example, we can see that, say, engineering and a few other fields, they use a lot of vision models. Whereas, for example, linguistics obviously naturally will use language models. So we can see those trends.
I noticed the time, so that's why I got up because maybe we should be closing. As you know, Andres, Antoine, and myself here, we researcher is very similar. And what is nice is that at least we're quite consistent in the results, right? Even when I see psychology here, it's very funny that we identify that psychology was. Andres, review, right? Psychology is one of the top in the social sciences that are adopting AI, which we didn't expect. So,
Yeah.
thank you very much.